Hello, and welcome to the Scientific Odyssey. The Scientific Odyssey is a mini-part journey into the history and philosophy of science. My name is Chad Davies, and I'm the writer, host, and producer of the podcast, where we consider the ideas, processes, and results of over 2,500 years of scientific inquiry and discovery. Series 2, A History of the Atom. Episode 2, The Athenian Response. Last week, we looked at the birth of an idea, that all things are made up of small particles called atomos, or atoms. What we want to do in this episode is to try and move the story forward. Before I do that, however, I need to make a correction to something I said in episode 2.1. The French chemist and philosopher of science Bernard Pullman wrote one of the sources I'll be using throughout this series. In the last episode, I mistakenly gave the wrong title of his book. It should have been The Atom in the History of Human Thought. I apologize for the error, and while the book can be a bit hard to find, I recommend it for anyone who'd like to dig around more deeply in the subjects I'm discussing in these podcasts. So, back to the topic at hand. Let's recall what Democritus said about his atomic description of the nature of both matter and the physical universe. 1. All matter is made up of tiny, indivisible particles that are in constant motion and interaction. 2. There are an infinite number of these things, and they come in an infinite variety. 3. Their combinations give rise to all of the different things we see around us, and their motion accounts for all of the change we see in the world. 4. They are able to move because of this thing called void in which they're able to move. When there isn't an atom at a particular point, that point is empty and thought of as being void. 5. The interactions of an atom with other atoms can impart some of the properties of the atoms being interacted with onto the original atom, which can then be transported to other atoms, thus giving rise to phenomena such as human sense perception. Now, though all of this seems pretty reasonable to us now, we should be sure to recognize a couple of things. First, Democritus puts forward this idea to explain the change we see all around us. He's responding to the school of thought of Parmenides and his followers who claimed that change is an illusion. Second, this is an argument made from rational considerations rather than from observation and experimentation of any sort. The argument for atoms at this point is philosophical, not empirical. So, why does it take us another 2 or so millennia before we arrive at the conclusion that Democritus's idea is more or less, with some modifications maybe, correct? That's a great question, and it's one we'll try to answer to some degree here in this podcast. The difficulty we're going to run into is the one I mentioned in the last podcast. We've got to determine the right flight altitude. 2,500 years is a long time to cover, and the details can get a bit overwhelming, especially as much of the work between about 500 BCE and the early 19th century CE is entirely philosophical. While my original plan was to try and cover all of that time in one podcast, I've realized that there's just too much to get through without this thing growing to monstrous lengths. So what I'm going to try to do in this episode is cover the developments of and objections to Democritus's ideas by other Greek philosophers so that we can get an understanding of why the idea of atomism went dormant for about 2,000 years. In the following podcast, I'll discuss how the idea was carried forward through the intervening time, and then deposit us in the 18th century, where science will have begun to develop the tools that will lead to an empirically supported atom. Using our airplane analogy, we're going to gain some altitude in this podcast, and then survey a broad landscape at altitude in the following one before descending back down somewhat. So why don't Democritus's ideas end up persuading everyone that the world is made of atoms and void? To answer this question, we need to take a few minutes to consider two giants of Greek philosophy, Plato and Aristotle. Both men lived, thought, and taught in the Greek city of Athens. Unlike the philosophers who we've mentioned so far, who lived at the edges of the Greek world, Plato and Aristotle were at the heart of it, in the city that would become known as the nerve center for Hellenistic art and culture. I'm not going to spend much time giving biographical information about the two men, nor am I going to give a detailed overview of the totality of their thinking. But if you'd like to find something more in-depth, I recommend you head over to the Philosophize This podcast, where Stephen West does a good job of introducing their ideas in layman's terms, using examples folks today can relate to, along with some pretty good humorous bits. What I'll try to do here is focus in on their metaphysics, specifically as it relates to Democritus's atom. So, let's start with Plato. To understand his thoughts on atomism, it's useful to take just a moment to sketch a brief overview of his metaphysics, as it influences his thinking on just about everything. First, Plato thought that the world we observe, the one that is always changing and becoming something different, is but an imperfect copy or reflection of something perfect that he called the realm of forms or ideas. This realm of forms was something higher, eternal, and unchanging, and it alone represented the true reality of things. Second, he said that the world we observe was fashioned by a sort of craftsman god who made all of the things that you see according to the forms and ideas of that higher realm. This craftsman creator didn't make the universe out of nothing, as the matter and ideas were already there. Because of this pre-existence of the building blocks, this God is constrained in its creative work by two overriding principles. He can only work with what he has, the building blocks that are already there, and he must act according to the objective to create the best possible world, an idea whose optimism was in contrast with many of Plato's contemporaries, who thought that the gods had purposely created a broken or marred creation for a variety of reasons. Third, while the present physical world cannot be fully understood and explained due to it being an imperfect reflection of the realm of forms, Plato still thought that there was value in exploring and investigating it. The hope was that the mind of the creator could be better understood through such an investigation, and that various laws of nature could be determined that would give insight into both the creation and the sources from which it was created. In this investigation, Plato clearly favored the use of reason over the use of the senses, as he felt that the realm of forms could only be properly understood through the application of logic. In this, Plato said that each person had an eternal soul that had once resided in that realm of forms, and thus had experienced all the things that were there. This pre-material experience gives the mind the necessary empirical evidence to understand that realm through rational means, and thus he thought that reason was a better path forward to knowledge. Any present empirical evidence would be flawed due to the profoundly imperfect nature of the world, and thus investigation based on the senses was really only something one might do for recreation. Finally, in trying to comprehend the world from the viewpoint Plato is putting forward, one had to add one final motive to the creator's work, and that was an aesthetic motive. In other words, in the work of creating, Plato's God had strived to make a world that was beautiful. In this, I see a sort of, Plato's razor, wherein Plato, somewhat like Occam, who had said that one should favor explanations that do not overly complicate things, had said that an explanation of a physical phenomena should be one that leads to the most beautiful world. So, to sort of understand all of these principles together, let's think of a person who lives in the everyday world you and I experience. Now, this person, however, is a little different because they're going to decide to create, or recreate, I should say, this world that we see using a very large set of Legos. You guys know about Legos, right? The little blocks that all snap together. They make movies about them now. Now, I think most of you have seen various Lego recreations of the kinds of things in this world. And while it can be fun to see what the creative minds of people can come up with, the blocky nature of the Lego imposes some limitations on the things that are going to be made. Still, the creator of our Lego world will work with the building blocks he has to make various things he sees his Lego world needing. He'll likely pick up things to copy that are particularly useful and functional for his world, but he'll also try to create a world that is enjoyable to look at and experience. And, of course, he'll also build a Lego Death Star because, well, that's just cool. In these tenets, one can see that Plato was strongly influenced by the earlier work of the philosopher Pythagoras and his followers. Their work centered on the perfection they saw in pure mathematics, most notably geometry. Plato understood that he could never draw a perfect circle in the dirt of the Agora of Athens, but he could imagine that figure described by the definition of all points in a plane that were equidistant from a single point. He believed that the only way he could do this was if his soul had encountered that perfect circle in another realm prior to inhabiting his body. Thus he extrapolated that this had to be true for all other things in this physical world as well. So, what does this all have to do with atoms? Well, this is where Empedocles comes back in. If you recall, Empedocles had thought that all things were made of 4 elements: earth, water, air, and fire. What Plato did was take that idea and combine it with the atoms and void description of Democritus to say that the elements were each made of specific types of atoms that could move or combine. To explain how this process of combination worked, Plato then borrowed from the mathematical work of Pythagoras. One of the things that the group around Pythagoras had shown is that there were 5 what we call perfect solids. A perfect solid is a geometrical figure where all the sides of the object are exactly the same. The one that everyone's familiar with is the cube, which has 6 identical square sides. It turns out that Pythagoras knew of 5 of these kinds of solids. One with 4 sides that look like a pyramid, the cube, and other figures with 8, 12, and 20 sides. Now, if you've ever seen the dice used in role-playing games, or sometimes they're called D&D dice, you've seen those 5 perfect solids. Plato, following a Pythagorean philosopher called Philolaus, assigned one of these solids to each of the 4 elements and then explained the combination process through a pretty elegant description of how the triangles that made up the sides of the solids interacted. The only exception to this was the 12-sided figure that is built from hexagons, which was reserved for a special 5th substance that Plato said was found in the space delineated between the edges of the atoms. In doing this, Plato seems to be the first person to think of atoms not as hard, indivisible objects, but as things that had sides and edges and that defined volume. Now, the specifics of Plato's geometrical descriptions are too detailed to go into here, but they are very much in keeping with a mathematical description that would have been right at home in the realm of forms. Writing in the Timaeus, Plato says, quote, "When God undertook to organize the whole, in the beginning, fire, water, earth, and air, all carried traces of their own essence, but they were in a state of utter disarray in which everything finds itself in the absence of God. In this state he took them and began to give them distinct configuration by means of ideas and numbers. That he extracted them from their disorder to assemble them in the most beautiful and best way, that is the principle that must guide us in our entire exposition." Unquote. In putting forward this mechanics of combination based off the shapes of the surfaces of the 4 elemental atoms, Plato is able to provide explanations for various chemical processes that would have been known to the Greek artisans and metal workers at the time. Because of this, some historians of science have said that Plato's work on the subject, the Timaeus, is the first treatise on chemistry. Others, however, are a little less generous in their praise, noting that Plato's contributions only moved the idea of atoms forward a small amount, while his focus on the realm of forms and the accompanying claim that it couldn't be understood through the use of senses would contribute to stifling scientific development in the West for 2 millennia. In closing this section, it is worth noting that nowhere in his writing does Plato even give the briefest mention of Democritus's atomic ideas. Apparently, Plato despised Democritus, feeling that all of his works should be burned, and thus never thought it was necessary to give the earlier Anatolian even the barest mention. Just because someone is capable of thinking some really deep thoughts about the nature of reality doesn't mean they can't be petty and hold grudges. Philosophers are people too. This brings us to the other giant of Greek philosophy, Aristotle. Aristotle was a student of Plato who disagreed with a number of his teacher's ideas and left to found his own school, the Academy. Aristotle wrote on such a wide variety of topics that there was scarcely anything that escaped his attention and commentary. Almost everything we think of as a field of scientific inquiry today is touched upon somewhere in Aristotle's writing. So what did he have to say about the nature of reality? What was Aristotle's metaphysics? First, Aristotle rejected Plato's realm of forms. He said that the only world that there is the one we experience right in front of us. Second, while embracing the elemental picture of matter put forward by Empedocles in part, he rejects Democritus's ideas of there being void and of matter having the smallest particle. In short, while embracing a changing world of elements, Aristotle is deeply and profoundly anti-atomistic. So let's examine what Aristotle's reasoning was for this. In explaining the constitution of the physical world, Aristotle said that all things had 2 guiding principles, matter and form. Matter was the stuff that things were made of, kind of like we've already been talking about, but form encapsulated the shape of the object as well as the purpose the object was created for. For Aristotle, it wasn't enough for there to be mere matter, as that didn't mean much. There had to be other considerations, or causes, as he called them. As an example, let's consider a bunch of building materials. Let's say that a builder has a whole lot of, wooden pieces and stones and cement and piping and wiring and all the rest of the things needed to build a structure. Now that's great, but it doesn't mean much if those things are all sitting around in piles, not assembled into anything. In the same way, if a builder has an architect create a plan to assemble a structure for people to live in, that doesn't do anyone much good without the building materials to construct it. However, once the 2 things are brought together in the right way, a structure can be created that will allow people to live comfortably and efficiently. As you can see here, you have to have both the stuff and the plan to make the thing. Now, an interesting twist on this is that if you change the plan, you can use the same building materials, say, to create an office that is designed for people to work and interact with others in order to conduct business of a certain type. You can have the same materials, but if you have a different form, you get a different thing. In one of his Philosophize This episodes on Aristotle, Stephen West uses the example of a smartphone to illustrate this same point. An iPhone and an Android phone are made of basically the same materials, but aren't what they are without the operating systems that run them. The specific ways in which the hardware and software of the devices are designed, as well as the designed interactions between these 2 things, is what makes them what they are and what differentiates them from each other. For Aristotle, in distinction to atomism, both matter and form are necessary to define objects in the physical universe. He encapsulates these in what he calls his four causes. And while an explanation of these is beyond the scope of this particular podcast, the enterprising listener might find it enlightening to spend a few minutes looking them up. They form the foundation of the Master of the Academy's metaphysics and come to dominate scientific thinking and investigation between roughly the years 1000 and 1500 in the late medieval and early Renaissance periods of Europe. Now, Aristotle's next objection to atomism has to do with the idea of combinations. One of the things many who opposed the idea of matter being made of discrete chunks of stuff, again, think of the Legos analogy here, pointed out was that it was fairly easy to break things down into atoms, but it was a whole lot harder to describe how one might put them back together again to make things that changed. In other words, without a molecular theory of some sort, it was really hard to explain how the medium-sized dry goods came to be, and more importantly, how they might change. Now, the way Aristotle accounts for change was to invoke two different things. The first thing he does is that in addition to the four elements, and as we'll see in a moment, a fifth, he said that all substances had a combination of four primordial qualities: dry and moist, and hot and cold found in pairs. Each element had a combination of two of these qualities, i.e. dry and cold for earth, or hot and moist for air, for example. Change in an object, therefore, could be affected by changing either the mixture of elements, how much of each type there was, or by transforming elements by changing one of the primordial qualities and thus changing the element itself. An example of the second process would be by changing the dry in earth to moist and thus transforming the earth into water, which has the properties of being moist and cold. The second part of the explanation that Aristotle would put forward to explain change was to say that there was more than just a clustering of like elements to make up something. Aristotle said there had to be what he called an intimate mixing taking place that gave rise to the properties of the substance. In this mixing, elements would lose their individual properties and thus cease to exist as distinct entities, thereby becoming part of a new substance possessing a unique set of properties in something akin to what we might think of as a chemical reaction today. Now finally, and most importantly, we come to Aristotle's rejection of Democritus's void. His arguments against the void all come down to his understanding of the causes of motion. For Aristotle, motion occurred in two basic ways. The first was what was known as forced motion. In his physics, an object only moved when a force was applied to it. If the force was removed, the object would come to rest. The mistake here is that Aristotle failed to understand what we now call the law of inertia, that says an object will move with a constant speed in a straight line unless there's a force acting on it. This misunderstanding led to the erroneous conclusion that the speed of a falling object depended inversely on the density of the material the object was falling through. The more dense the material, the slower you fell. Thus, Aristotle argued that there could be no void because a falling object would then have to have an infinite speed. The second type of motion for Aristotle was what he called natural motion. In this, Aristotle said that elements will move to seek their natural place. Hence, air and fire will naturally travel upwards, and water and earth will travel downwards. To this, Aristotle adds a fifth element he calls ether, that is found only in the celestial realm. Objects comprised wholly of ether will naturally move in circles. Using this picture, Aristotle argues against the existence of the void by saying that in void there is neither up nor down, and thus, if there was void, none of the elements would have a natural motion, and thus nothing would ever move. In these two arguments, Aristotle therefore concludes that the void is incompatible with the idea of motion, as it gives nonsensical results, and thus he rejects it. Once he rejects the void, he must also reject the existence of atoms and come to the conclusion that matter is continuous. An additional consequence of these arguments that will have a lasting impact on Western thought is that there is now a fundamental division between what makes up the terrestrial realm of the universe and what makes up the celestial. Thus, the laws of motion that govern things here on Earth are going to be fundamentally different in Aristotle's description than those that govern the motion of the objects in heaven. Unfortunately, the ideas first of Plato, then Aristotle, become the dominant frameworks through which the metaphysics of everything will be conceptualized for the next 2,000 years. I'll try to explain why in the next podcast, but there are a few things that should be expressed here prior to moving on. It's easy to blame Aristotle for derailing us from the correct path of physical thought for the 2 millennia. Certainly his mistake about the law of inertia is profoundly damaging. However, there are a couple of quotes that shed a little bit of light on this. Historian of science Alexander Korah is quoted by Pullman as observing, quote, "Aristotelian physics is wrong. That is quite obvious. It is hopefully obsolete. But it is a physics nonetheless. That is to say, a theory that is rightly, if not mathematically, elaborated. It is neither a crude expression of common sense or a childish fantasy, but a genuine theory, in other words, a doctrine that starts with common sense data and subjects them to an extremely coherent and rigorous systematic analysis." In other words, let's give Aristotle some credit for putting his thoughts down in a way that could be tested and which were logically consistent with his other conclusions. Yes, he was wrong, but that happens a lot in scientific investigation. We really shouldn't blame him for the lack of will to challenge his ideas that descends over the Western mind for the next 2,000 years. As Bertrand Russell puts it, quote, "In reading any important philosopher, but most of all, in respect to reading Aristotle, it is necessary to study him in 2 ways, with reference to his predecessors and with reference to his successors. In the former aspect, Aristotle's merits are enormous. In the latter, his demerits are equally enormous. For his demerits, however, his successors are more responsible than he is. He came at the end of the creative period in Greek thought, and after his death it was 2,000 years before the world produced any philosopher who could be regarded as approximately his equal. Towards the end of this period, his authority had become almost as unquestioned as that of the Church, and in science as well as in philosophy, had become a serious obstacle to progress. To do him justice, we must, to begin with, forget any excessive posthumous fame and the equally excessive posthumous condemnation to which it has led." Unquote. It's not Aristotle's fault that the later Greek and Roman world ignored the work of Archimedes that was headed in the right direction on understanding the correct laws of motion. Nor was it Aristotle who condemned the work of Copernicus, Kepler, and Galileo in the 16th and 17th century. It is appropriate to judge Aristotle on his ideas at the time rather than on the slavish adherence to them that develops after his death. To conclude this podcast, let's take a few minutes to talk about Epicurus and Lucretius. Epicurus is a mostly ethical philosopher who is primarily concerned with how one lives the good or the happy life. His answer to this question is founded on the belief of a completely mechanistic universe devoid of gods. His conceptualization of this picture is completely atomistic in stark contrast to Aristotle. Starting with the ideas of Democritus, Epicurus adds to the atom the property of weight. This allows atoms to aggregate together rather than just bouncing off of each other infinitely, which means that they're now able to form things by remaining in place for a certain amount of time. Additionally, he said, again in contradiction to Aristotle, that all atoms move through the void at roughly the same speed. Now, the problem with atoms now having these 2 properties is that those properties result in a motion where all the atoms should travel to the bottom of whatever there is, something like them falling. And they're going to do that without actually interacting with each other. To deal with this problem, Epicurus has to invoke a mechanism wherein each atom can undergo a little, what he calls a swerve, in its trajectory in order to interact with other atoms and thus give rise to structure. Unfortunately, Epicurus never really explains what causes this swerve and is, understandably, subjected to a good bit of ridicule from his contemporaries in his invocation of this sort of, I guess you'd call it a miracle. Now, Lucretius was a Roman philosopher who followed the teachings of Epicurus about 200 years after his writing. Writing around 75 BCE, he was a staunch atomist, just like Epicurus and Democritus before both of them, who worked to put forward the ideas of both to the wider Roman world. What is most notable is his attempt to deal with Epicurus's miracle of the swerve in an unbiased way. In doing this, he arrived at a picture of atomic motion that resembles nothing so much as the modern atomic idea of Brownian motion, something we'll have a lot more to say about in a future episode of the series. Additionally, he reinforced the idea, first expressed with Democritus, that the soul, whatever it might be, is made of atoms and is, like all other things so constituted, of finite duration. His picture of a world without gods, wherein the complete existence of a human being is limited, stands out as unique among the thinkers of his time. As you might imagine, this paradigm, while compelling to a few individuals who found the idea of non-eternal existence unthreatening, was not well accepted by those who sought a more, how shall we say, permanent disposition for the fate of a person. In the next episode, we'll examine the way forward as the ideas of the atomists are rejected, occasionally rediscovered, and finally reconsidered in that episode I'm calling The Long Leap Forward. So until next time, full sails on your journey.